Welcome to my channel. Today I will show you how to draw linear regression line by using Graphpad Prism. Let's start. First you have to click XY, that will be the XY type graph, and then X is by default, it will be number, but if you have different like date or others you can choose it. In my case it's number, and I have three replication. You have one point or one single value, then you can click here. I have three replication, so I can click here for three, right, for three. Okay, and then you can click just create. So this appearance, and I already copied the data. These are my data. These three are control data, and these three are treated data, and in x-axis it should be the time like days in my case. So these are the days, and control data, three control data, replication, three replication, and three treated data. Let's look at the graph. So these are the graph, so you can click OK. So these are my graph data and need data. So let's check about the analysis. So you can click here directly for analysis, or you can go here for analysis. You can click here analysis and then simple linear regression, and then click OK, and then this will come. Or you can click directly in here analysis, then this drop down menu bar will come, parameters for simple linear regression. So I want to test whether slope and slope significantly differ. I can compare this, and I want to see the graph confidence 95 confidence level, but you can change it. If you need 99%, then you can click here. Otherwise I need only 95% confidence level to check the significance. And each replicate y value, as I use three replication, so I want to check whether these three individual point are linearly regretted or not. Or if you can check, you can check only the mean value also, it will be okay. I check individually point, and others are whatever it is, you can keep it. It's auto, range should be auto. So if you want, you can change it and then click OK. So this our line. You have seen there are three line. One is the best fitting, and another are like predicted line. These are the predicted line, so I don't need the predicted line. I only need the best regretted lines. So you can just click here, appearance only mean, don't need any error or others. So it will come like this way, and here also I don't need any other line or error bar, only mean. So right, so I find only two line, for one for treated and one for control. I can change the color. You can change the color. For example, in this one is black, I need this one red. Okay, and then in case of control, I need green. Okay, apply. Now you have seen these two, and also you can change the point symbol. This one also you can keep at it is a little bit change, like the green. Okay, perfect. So these two are control and treated. Now we want to check about our analysis, simple linear regression analysis. Right, these are the result. In result you have seen that best slope, best fitted value, slope and intercept, and standard error, slope and error, both for both control and treated, and in 95% confidence level, slope and intercept. And this is important, that goodness of fit, that is the r square value, it's 0.97, that's good. And in case of treated it's 0.96, and slope significantly non-zero, f statistics 662, and in p-value is less than 0.001, that is significant. That means our control and treated, they are significantly different to each other, and this equation is important. This is the y equal to mx plus c, y equal to mx plus c. Here slope is 5.257. It's already explained here in slope range, and in intercept also 10.19, so plus 10.19, and so it's explained here. So we need these two data. And another one is our lines different. It will say our f study is 62 and nominator 1 and 32. If you check in f statistics, you will see that our calculated value is higher than the tabulated value. That means we can reject null hypothesis. That means our lines are significantly different to each other. I have the one video on biostatistics, you can check there for interpretation. So here they mention that because the slopes differ so much, it's possible to test whether intercept differs significantly. That means our control and treatment are significantly differ to each other. Let's again go to the graph. Here you can check, for example, this plant height or whatever in your case the data is, you can put, and this is the time date. So in time days, plant height is increases in treated and control. And you can also do right click here and then insert info analysis consent. Then you can click here for control. Then I need the equation. So this equation for control, I can little bit here, and this one is control equation y equal to mx plus c. I need inside info analysis consent, I need r square value. So goodness to fit, you can click here and take the r square value. Okay, so this r square for right, you can also edit here. This is r square value, so r square. And in case of treated, you can also insert an info value. For treated, click here, this is the equation, and this is the r square value. It will come only one egg, and then you can again go there, insert analysis consent, treated, click, and goodness of fit, r square value, right. So you can click both of treated and r square value here, right. This one is equation and this one is r square value. Okay, r square value. Okay, so now we have seen that treated and this one is treated and this one is control. Our control and treated, the significantly differ to each other. Then you can click here and take one. Okay, and then they are significantly right. And after that, you can export your graph here. In case of TIF or JPG, whatever you want, and just export it. Okay, so yeah, this is your publication, ready to publication type graph for linear regression line. Thank you very much for watching.